Okay, we are continuing our discussion today, analyzing the graph f of x equals negative x cubed plus 3x. Now, keep in mind, this analyzation doesn't include graphs that have asymptotes. Right now we're just dealing with a continuous polynomial function, so we don't have to worry about whether it has asymptotes or discontinuity or anything like that. So I'm giving you a continuous polynomial function. We're going to break it down. First thing we're going to do is find all zeros, okay, which is letter A. Zeros happen where y equals 0. In other words, where f of x equals 0. So we set 0 to negative x cubed plus 3x. How do we find these zeros? Well, we factor. 0, we can pull out a negative x times x squared minus 3. And we could look at this part of it as the difference of two squares. So 0 equals negative x times x plus 1, x minus 1. X plus 1, x minus 1 is, look. We got this far in class today. The square root of 3 would be the square root of 3. We have negative x times x plus the square root of 3, x minus the square root of 3. If any of these is 0, then the whole thing's going to be 0. So that gives us three solutions. X equals 0, x equals negative the square root of 3, and x equals the square root of 3. Okay, so now we found our three zeros. The second part of this would be finding, these are our zeros. The second part is to find the y-intercepts. Well, that's easy. We already see if x is 0, 0 plus 0 is going to be 0. Our y-intercept is 0. So in other words, we set x to 0, solve for y, and we would get 0. So our y-intercept then is 0, which is the point, of course, the origin, 0, 0. All right. Part B, finding the first derivative, which we also already did in class. Okay. The first derivative, f prime of x, is negative 3x squared plus 3. Part C, find all critical points. Critical points occur where the derivative is undefined or 0. Well, here it's not going to be undefined. We can put in any value for x. So we're going to set it equal to 0. So we're going to set this equal to 0. That's how we're going to find our critical points. And the nice thing we could do to make life easier is divide by negative 3. Negative 3 divided by negative 3 is 1 times x squared, plus 3 divided by negative 3 is negative 1. 0 divided by negative 3 is just 0. X squared minus 1 is 0. X then is 1 or negative 1. Okay? 1 squared minus 1 is 0. Negative 1 quantity squared minus 1 is 0. So those are our critical points. They occur where x equals 1. These are the x values of the critical points. To find the actual critical point, we'll plug back in. If we plug in 1 to our f function, f of 1 equals negative 1 cubed, which is negative 1, plus 3 times 1, which is just 3. So negative 1 plus 3 is 2. F of negative 1 is negative of negative 1 cubed. Negative 1 cubed is negative 1 times the negative is positive 1 plus 3 times negative 1, which is minus 3. We get minus 2. Okay, so our two critical points are 1, 2, and negative 1, negative 2. Sometimes when we say critical points, we just refer to the x value, but these are the points that you're going to see on the graph itself. We'll continue in the next video.